June 30th, 1908. A calm summer morning over the isolated Tunguska River basin in central Siberia. 40 miles away from the basin's center, a man sat on his porch, feeling the early sunlight on his face. Without warning, a concussive wall of kinetic force threw him backward out of his chair. In that same fraction of a second, the heat flared so intensely he felt as though his skin had caught fire. He had just survived the outer edge of an explosion 1,000 times more powerful than the atomic bomb dropped on Hiroshima. A detonation of this magnitude over a city would have been an apocalypse, but because it occurred over an uninhabited expanse of the Siberian forest, the immediate human toll was minimal, leaving the exact mechanics of the blast a mystery for decades. This seismograph recording represents the immense reach of the blast wave. The force of the detonation drove downward, registering as a 5.0 on the Richter scale, despite the fact that the explosion happened miles above the surface. The physical shock waves pushed outward, shattering windows hundreds of miles away and physically rippling across the European continent. High in the upper atmosphere, tons of dust and debris reflected the sun's rays, keeping the night sky brightly illuminated across Eurasia for weeks. The glow from the atmospheric dust was so intense that over 3,000 miles away in London, people were able to read their newspapers in the middle of the night. Yet nobody immediately went to investigate the epicenter. Siberia was notoriously remote, and as the globe spiraled into political turmoil and the First World War, the site was entirely ignored by the scientific community. The largest impact event in modern human history was simply left alone, buried in the snow for nearly 20 years. In 1927, Leonid Kulik finally took up the case. As chief curator of the St. Petersburg Museum, he wanted to locate the rock. Reaching the site required an agonizing trek deep into the Siberian wilderness, a journey that dragged on for weeks through freezing temperatures and dense brush. When Kulik's team encountered the local indigenous population, they found people entirely unwilling to guide them anywhere near the impact zone. The survivors believed the blast was the work of Agdi, a god who had descended from the sky to punish them by incinerating their land and their reindeer herds. Kulik arrived armed with the rigid logic of a museum scientist, expecting to dig out a rock, but the locals were describing a terror that fell from the sky and simply vanished. When Kulik finally breached the epicenter, the destruction defied expectation. Spread across a massive 600-mile radial pattern, 83 million trees had been violently knocked flat. But as he reached the absolute center of the blast zone, the landscape changed. Instead of being knocked flat, the trees here were standing perfectly straight up. Every piece of bark and branch had been violently stripped away by a severe downward force, leaving a concentrated cluster of charred, upright pillars. And directly beneath these standing dead trees, there was absolutely no meteorite. Kulik scoured the earth, but he could not find a single impact crater. A kinetic strike capable of leveling millions of trees without leaving a single dent in the ground broke the accepted rules of planetary impacts. The mechanics of the event had to be entirely reimagined. Modern calculations point to a specific astronomical profile: a space rock roughly 200 feet wide, weighing over 220 million pounds, tearing into the atmosphere at 33,000 miles per hour. Extreme atmospheric friction heated the mass to 45,000 degrees, triggering a catastrophic mid-air detonation, an airburst. At ground zero, the shockwave hammers straight down. It strips branches while leaving central trunks upright, even as expanding lateral force flattens everything further out. Over the years, alternative theories have been proposed, ranging from a hidden impact crater beneath Checo Lake to a lightning strike igniting a huge vent of methane gas. The physical evidence leads back to the sky. The missing crater is the signature of a rock that annihilated itself miles above the forest floor. The Tunguska Event provides a historical baseline for modern astronomers, modeling what happens when a rock of this size intersects with Earth today. If an airburst of the exact same size and trajectory occurred over a densely populated region, it would level an area the size of Tokyo in a matter of seconds. By tracking near-Earth objects, scientists have calculated the astronomical mathematics. A space object of this mass hits our atmosphere roughly every 300 years. We are over a century past 1908. Based on statistical probability alone, humanity is mathematically due for another Tunguska-level event in our near future. A rock weighing millions of pounds erased 83 million trees and vanished without leaving a dent in the earth. It is a quiet reminder of the massive, invisible threats passing just outside our atmosphere every single day.